Okay, guys, so this is going to be our last set of notes for this unit. And for this set of notes, we're talking about something called power. So your topic here, I'll use this. Okay, so your topic here is going to be power. Um, and then the essential question, okay, is going to be what is power and how is it calculated? What is power and how is it calculated? Sorry about the handwriting. Um, okay, so when we talk about what is power, okay, um, so first off, we're going to come up with that. I want you to leave space for that definition, but I want to talk about just kind of try and explain this first. So if we think about, let's think about a situation here. Okay, so let's think about if you had to carry a box up the stairs. So let's say you had to carry a 25 kilogram box up the stairs, and the stairs were 6 meters high. Well, we know that the work would just be the energy used. So how much energy you would use, and we know that it doesn't matter how long it takes you. So if you walk really, really slowly, or if you run up the stairs, it's still going to be the same amount of work. It's still going to be the same amount of energy used. Um, power um, power takes speed into account. Okay, so if we looked at this same situation here, we would say that it takes more power to run up the stairs than to walk up the stairs. Okay, so power ends up being work done over a period of time. So time ends up being the really important factor in power. So it's how much work done, and then how fast is that work done. So let's go ahead and let's do an example, and I think it'll make more sense to you. Okay, so we'll draw a squiggly line. And here's our example. So let's say that this same flight of stairs, okay, so 25 kilogram box is lifted 6 meters, and let's say we did that in 6 seconds. We want to calculate the power that was used to lift that box. So here's how we look at power. Power equals work divided by time. So we first need to calculate work, and then we'll divide it by time, okay? So work, we know that work is just change in energy. So if I think about this box, the box is starting off on the floor, and it's got 0 joules of potential energy. When it's lifted up to the top, I've given it some energy. So how many joules of potential energy does it have now? And then the difference between 0 and that number up top, that'd be my change in energy. So I know that Eg is going to be equal to m times g times y. So I'm just going to plug in my numbers. I know that my mass is 25 kilograms. So Eg equals 25 times 9.8 times my height. And my height is 6 meters. Okay, so I'm going to do it on my calculator real quick. 25 times 9.8 times 6. That doesn't seem right. 25 times 9.8 times 6. That is right. Okay. So EG is going to be 1,470 joules, which is the same thing as my work. So work is 1,470 joules because that's how much energy I had to put into the system. So I'm just going to take that and put it back here. So my power now is going to be 1,470 divided by my time, which is 6 seconds. So that's going to go in there. So I've got 1,470 divided by 6, which is 245. And if we think about that, this is joules, this is seconds, so that's going to be joules per second. So that's my power rating for carrying that box up those stairs. Now, one last thing, okay? We're going to have a new unit. Joules per second is the same as watts. So if you've heard the word watts before, watt tells us how much power something has, and we're just going to use W. So really, I could write this out as 245 watts of power. Okay, there we go. Let's start on the worksheet.